So in this video, we are going to proceed with the previous video, which has described about the statistical hypothesis test for comparative numeric. So comparing means between groups or between variables. So we have discussed in the previous video how to do an independent or unpaired t-test, and how to do a paired t-test, and how to do a one-way ANOVA in terms of data that are normally distributed. So for parametric tests. In the previous video was also described about how to do a Mann-Whitney-Hughes, Wilcoxon and Kruskal-Wallis, and also Friedman test for skewed distribution or not normally distributed data or non-parametric analysis. In this video, I will share you about how to conduct two kinds of categoric comparative analysis. So previously we were comparing numerical values, which means that we are comparing means. And now we're going to compare data that are categoric, for such as education, like lower, mid, and high, or categorical, such as gender, female and male, and so forth. So for how the algorithm for the statistical hypothesis test for the categorical comparative analysis is a bit similar with how the algorithm is in the numerical comparative analysis. But for the categorical, we're not comparing means because, like gender, there are no means, right? Such as if the female is 1 and the male is 2, giving the codes or values in the SPSS, there are no such thing as mean of gender like 1.5. So there's only percentage or proportion, how many are female and how many are males. The same thing, we have to think about whether the categorization or the groups are only one group or two groups, such as gender, female and male, or it is more than two groups, such as education, such as lower, mid, and high school or so. And then the same as well, we have to look whether the data or the categorization is unpaired or paired. Unpaired meaning if you want to know whether there are difference in educational attainment between gender. For paired one is if you are trying to measure in the same sample twice, such as looking at whether a person or the sample previously or the baseline, whether they have dental caries or not, and then after 1 year they are being analyzed again, measured again the samples, whether they are already dental caries in the sample. So it's the same measurement on the same sample. So for the more than two groups, meaning that again, like education attainment and so forth, and then unpaired and paired too. But for this time, I'm only going to share about how to do continuity correction, Fisher exact, and Pearson chi-square. But the most used is Pearson's chi-square and continuity correction. If you read journals, you will see that all these tests are usually called chi-square tests. So whether it's continuity correction, Fisher exact, or Pearson, they will call it a chi-square test. Okay, for the others, never mind. We will share it again in another video. After we're going to do the categorical comparative analysis, later on I will share as well for the correlative analysis, whether there are correlation between two variables such as height and weight or something, or whether there are if the plaque index is increasing, whether the dental caries, the number of teeth that has dental caries is also increasing or not. So for these two algorithms are for comparative. So comparing means and comparing proportion. But for this one, it's more to correlation. Whether something is, if something is going high, the other variable, is it going to be high too, or is it going to be decreasing? Okay, so I have prepared a data set. Here I call it data 2. It has the same variable with data 1, plaque index before, plaque index after, and then education attainment and number of tooth decay, and then gender. And I added a new variable here, erosion, dental erosion, whether someone has dental erosion or not. In terms of number of sample, I added as well to give you more insight on how data analytics is. So here you can see the name of the variables, and then making sure the decimals, which variable should has decimal and which not, and then labeling the variable and also valuing the variable if it is needed, and making sure that we jot down the measures as well. Here, erosion, I put ordinal, although there are only two categories. Yes, having dental erosion, and no, having no dental erosion. Because it's an ordinal one, so one is good and one is not, therefore I put it ordinal. Doesn't mean that the one variable, if only having two categories, then you are sure that it is nominal. Sometimes only two categories, it's called also ordinal. Okay. So first, we need to think about what kind of hypothesis could be tested with this kind of data. Or if you're writing up a proposal, you will jot down the hypothesis of your proposal. In this data set, maybe we could try to compare categorically whether there are difference of dental erosion status between gender. So we are going to compare between female and male who has more dental erosion. So for this kind of data analytics, we are going to use chi-square test, whether it's Fisher-Isaac, continuity correction, or Pearson. For categorical comparison, we click Analyze and go to Descriptive Statistics, and then go to cross-tabs. Cross-tabs means cross-tabulation. You can see here there are 3.3 tabulation with some kind of cross. You click it there. Let me see, do the reset. For the row, we put the independent variable. In this hypothesis that we're going to test is whether there are difference in dental erosion status between gender. So the gender is going to be independent variable and the erosion is going to be the dependent variable. Don't forget to click statistic and make sure you click the chi-square test because we're going to do the chi-square test. And then click continue. And then click another box, which is cells. Make sure that you click the expected counts and also the percentage of row. So click expected and click row, and then click continue. That's it. So we're going to test the hypothesis whether there are difference in dental erosions between gender. Okay, you can see here at the chi-square test, there are Pearson, continuity, and Fisher-Isaac. And look at the below mentioned sentence below the box or table showing that 0 cells have expected count less than 5. Maybe you still remember I showed you a diagram on for numerical data, you look at the normal distribution, but for categorical data, you're not you don't analyze the normality because as I told you that like gender, there's no mean. So for normal distribution test, or this for distribution test, it's only for numerical data. Here it is, we call it expected count less than 5 and more than 20% of cells. For now, I don't think I'm going to explain more in this video, but just have in mind, if it is reported below the table at the output of SPSS, whether there are expected count less than 5 and more than 20% of cells. You can go again here. It turns out no, 0 cells and 0.0% have expected count less than 5. Therefore, looking at the algorithm again, if there are non-expected count less than 5 and more than 20%, because at the output we look at 0 and 0.0%, it turns out we are going to look at the continuity correction results. So in the chi-square, it's different with the numerical comparative analysis. All the values are coming out in one click, in one output. So it's the chi-square test, continuity correction, and Fisher exact, right? So because there are no cells that are less than 5 and more than 20%, you look at the continuity correction. You look at the significant two-sided, this one. So this is the result of the comparison of dental erosion between gender. Because the number, the p-value is below the alpha we put 0.05 here. So it turns out that it is more than 0.05, meaning that there are no difference of erosion, dental erosion status between female. We can see at the box above it that there are 10 males that don't have erosion and 4 males that have erosion. And there are, here you can see 53% have no dental erosion for female, and yes, 46% of dental erosion. Statistically, it seems that 73, 26, 53, and 46 don't seem that there are statistically significant difference between the number of female or male that has or don't have any dental erosion. So we can conclude that the hypothesis is, we can accept the hypothesis that there are no difference of dental erosion between gender. Okay, I'm going to share you again about conducting a comparative categorical analysis. Now we would like to test the hypothesis whether there are difference between gender in terms of education, whether female or male are more highly educated or not. Again, we go to analyze because education and gender are both categorical data. Education, we call it here ordinal, and for gender, it's nominal. So categoric meets with categorics, right? So you click analyze, you click descriptive statistic, and again, you click cross tabs. This was the earlier test. We can do a reset. And then we would like to know whether there are difference in education attainment between gender. So gender would be the independent variable and education would be the dependent variable. And then you click statistics, make sure the chi-square test is clicked, and then go to cells, make sure the expected and the row are clicked as well, and click continue and click OK. Here, this test, you can see that the continuity correction and Fisher exact are not apparent in the chi-square test analysis output. It's only Pearson chi-square, so it's quite easier to jot down that we should be looking at the Pearson chi-square. If you look again at the statistical algorithm, that if you have more than two groups, uh, here we have three categorization of education attainment. So we just look at Pearson. You can hear Pearson, the significant two-sided is below 0.05, meaning that there are difference between gender in terms of education attainment. Here you can see that the female are more in the high school, and then the male are, if you look at 1, 4, 10, are more in the elementary school. So you can compare that. It looks like the female are more educated than the female in terms of this data set or this research. So yes, the substance and the statistical test showed that yes, there are difference of education attainment between gender. Okay, done. So we have tested two hypotheses for this research over this data set. So further, I will continue with the correlative analysis. The same again, it's quite easier than the numerical comparative, which all the tests having their own clickers in SPSS. But for correlation, it's a bit quite easier. So for if you have numerical data and then another numerical data such as weight and height, and they are normally distributed, you should use the Pearson analysis or Pearson results. And if one variable is not normally distributed, you should use Spearman. Or if both of the variable are not normally distributed, or if one variable is a numerical value and the other one is categorical. So Spearman is quite widely used because you can use it for numeric with categoric. You can use it for numeric normally distributed and numeric not normally distributed, or if both variable are not normally distributed. For Pearson, it has to be both normally distributed. And then if you have categorical with categorical data, you should go to Kendall. Okay. I will go to the data here. We can see that we have the plaque index before intervention and then plaque index after, and then we have decay. It might be the hypothesis for this study would be the higher the plaque index or the what do you call it? The oral hygiene is bad, are correlated with decay. The more the PI or plaque index is, most likely the person have also higher tooth decay or number of tooth decay rather than those who does not. So for that hypothesis, we need to see that the plaque index before is a scale measure and the decay is also a scale measure. So numeric meeting numerical values. Therefore, if we have numerical values, both numerical values of the variables, we need to do the normality test first. You can go to analyze descriptive statistics and go to explore. Okay, I'll reset. So we are going to correlate whether there are correlation between plaque index before and the number of tooth decay. Make sure both of them are putting in the dependent list, not in the factor list. So we would like to know whether there are correlation between the plaque index and the number of tooth decay. Don't forget to click plots and make sure, sometimes I just unclick the steam and leave, and then box plot, I don't want to have that currently. And don't forget to click the normality plots with test. This is the most important thing. And then click continue and click OK. Click the test of normality here. You can see that plaque index before intervention and number of tooth decay. Because the number of sample are below 50, you look at the Shapiro-Wilk test. Here you can see that the plaque index before has the normally distributed data of higher than 0.05, meaning the distribution is normally distributed. As well as the number of tooth decay, it is above 0.05, meaning that the distribution of number of tooth decay are normally distributed. Therefore, if we look again at the algorithm for normal distribution, both variables are normally distributed. We're going to use the Pearson correlation test. Okay, if we go here, you should click Analyze. And then here you have the correlate. So we have done the compare means, right, for the numerical comparison. And we have done at the previous video for the non-parametric test, right, for this 4 tests. And we have also used the descriptive statistic for cross-step for categorical data. And for correlation, we have correlate. So if you would like to correlate two variables, you click correlate, and we are going to tell SPSS, I have two variables that we want to correlate. So by variety correlate. Okay, I will reset this. Okay. So by default, if you reset, you have a bivariate correlation. It's normally set in the Pearson. So if we want to test the plaque index and also the number of tooth decay, we don't have to click anything else because it's already by default clicked in the Pearson correlation coefficient. And then that's it. Click OK. Okay, here the correlation result is quite easy to detect. It's only one table. You can see first, it's okay to look at the upper or also the lower because it's just the same thing. Here you can see that the correlation is significant because it's below 0.05. If the significant here, the p-value here is above 0.05, so it means that there are no correlation between the variables. You don't need to look at the Pearson correlation. But if the p-value is below 0.05, look at the Pearson correlation here. It turns out the correlation is 0.8. So as you know, correlation is between -1 and 1. So if it's near to 1, it means that there is quite a strong correlation between plaque index before intervention and number of decay, meaning that the higher the plaque index is, the higher the number of tooth decay of the sample is. So it's done. We have tested the hypothesis that there are correlation between plaque index and number of tooth decay. Okay, here we have done the number of the test of Pearson tests. If we go again, if you'd like to try another example, looking whether I think I have prepared plaque index after to be non-parametric or to be not normally distributed, and then also with decay. First, because plaque index after is scale and also decay is scale, we need to make sure that we do the normality test first. You click Analyze and then Descriptive Statistics and then Explore. So we have here, go to Reset again. We want to know whether the plaque index after and the tooth decay are normally distributed or not. Click Plots, unclick the stem and leaf, box plot of none, and normality plots with test. And then continue. And then OK. And then click here, test of normality. Okay, because the number of the variable is less than 50, you look at the Kolmogorov-Smirnov test, and both of them seem to no, just one. One of them are not normally distributed. This one, because it's below 0.05. This one is higher than 0.05. So if you have one variable to be normally distributed, and the other variable is not normally distributed, if you go again to the algorithm here, you use the Spearman correlation. because Pearson, both of the variable needs to be normally distributed. Okay, so we shall try to test the hypothesis whether there are correlation between plaque index after intervention and decay. You can go to analyze and then correlate and bfarad, and then you just reset it and put the after one and also the number of decay. Because by default it's in Pearson, you have to unclick the Pearson and unclick the Pearson. Click the Spearman, sorry. Click the Spearman and unclick the Pearson because one of the variables are not normally distributed. The plaque index after intervention is not normally distributed. So you should use the Spearman correlation coefficient and then just click OK. Go to the correlation results. Okay. Here you can see that the significance is below 0.05, meaning that there are significant correlation between plaque index after intervention and also the number of tooth decay, showing a quite high correlation of 0.8 because it's quite near to 1. So done. So we have done the Pearson statistical test and Spearman correlation test. Okay, maybe I can share you just one more for the categorical one. Categoric with categorical. We can go to maybe education with oh, it's like 2.3. Oh, I think that's enough. So if just make sure if you use the correlation here, make sure you know which correlation coefficient you're using, whether it is Pearson for both variable to be normally distributed, or Spearman if one variable is not normally distributed, or both variable are not normally distributed, or one variable is categorical, and use candle tau if both of the variable are categorical in values, as this algorithm is showing. Okay, I think that's all for categorical comparative analysis and for correlative analysis. Thank you.